Hello everyone. So in this lecture we are going to discuss BARC memory based previous year question. Okay, so this is your memory based previous year questions of BARC. Okay, so first question is hyperfine structure splitting occurs due to. So here we are asked that hyperfine structure स्प्लिटिंग अकर्स ड्यू टू. जो हाइपरफाइन स्ट्रक्चर का जो स्प्लिटिंग होता है वो किस वजह से होता है वो हमें पूछा गया है. सो एज वी नो हाइपरफाइन स्ट्रक्चर स्प्लिटिंग जो है वो न्यूक्लियर स्पिन और जो टोटल एंगुलर मोमेंटम है ऑर्बिटल एंगुलर मोमेंटम उन दोनों के इंटरेक्शन की वजह से होता है. सो हाइपरफाइन स्ट्रक्चर स्प्लिटिंग इज ड्यू टू interaction between nuclear spin and angular momentum. So the correct option will be B. It is due to existence of nuclear spin because hyperfine structure splitting involves nuclear spin. Okay, so option B will be correct. Then second question is what is partition function of two bosons occupying two energy states. So here we are asked for partition function. So as we know the formula of partition function is given as z, that is partition function is equals to sigma gi, where gi is e raised to minus beta ei, where gi is degeneracy factor and beta 1 upon kt and ei is energy. So here we are given two bosons. How many bosons? Two bosons. So for two boson we know boson can stay in same energy state. So here we have two bosons. So first of all we have two energy state. We have energy state E and one energy state we can assume ground state. Okay, and two identical bosons. So how many possibilities are there? So first possibility is that our boson both boson stay in ground state. So this is first possibility when two bosons are in ground state. Then second possibility is that one boson stay in ground state and one boson stay in E energy, and third possibility is that both boson stay in higher energy level state, that is E. Okay, so we have three possibilities which I tried to denote by different colors. So first yellow color shows first possibility, that is both boson stay in ground state. Second blue color shows second possibility, that one boson stay in ground state and another boson stay in E energy level. And third is I shown by green color, that is both boson stay in E energy level. So now I write in partition function. So partition function will be, so here in first case both are in zero energy level. So what will be our summation? That will be e raised to, for first energy level, first state yellow state energy is 0. So it will be e raised to minus beta and energy is 0 for first possibility. So I put here 0. Then second one is in here blue color. So in second one the energy will be E only of this boson. This boson have only energy E. This boson energy is 0, ground state energy. So I write for second is e raised to minus beta. One boson is E energy state, so energy will be E. And for third possibility our both bosons are in E energy level, so energy will be 2E of these two bosons. So it will be plus E to the power minus beta, and energy is 2E. Okay, so now E raised to beta into 0 will be 1, then plus E raised to minus beta E plus E raised to minus 2 beta E. So this is our partition function. Okay, so the correct option will be 1 plus E raised to minus beta E plus E raised to minus 2 beta E. The correct option will be C. Now third question, which is from matrix. In third question, we are given that we have 2 cross 2 matrix. A is equals to 1, 2, 2 into 3, and we are asked to find the product A transports into A. So okay, so here for A square and A transport A. So what we do for A square? So A square will equal to A into A. So 1, 2, 2, 3, and again 1, 2, 2, 3. Okay. Now this 1, 2 will multiply by this 1 and 2. So first row, first column, 1 1s are 1, and these 2 2s are 4. So 4 plus 1 will be 5. Then first row, second column, first row and second column. So 1 2s are 2, 2 3s are 6. So 2 plus 6 will be 8. Then second row, first column, and second row, second column. So 2 1s are 2, 3 2s are 6. So 2 plus 6 will be 8. 2 plus 6 will be 8, and then second row, second column, 2 2s are 4, 3 6s are 9. So 4 9, it will be 13. So this is our A square. And now we have to take transpose of A. So A transpose will be like this, that is A transpose. In A we are given 1 2 in row and 2 3 in row. So we take transpose and change our row into column and column into row. So this is 1 2 row and 2 3 row. So I transport is 1 2 column and 2 3 column. And what we have to do now? A transpose into A. So this is my A transpose, 1 2 2 3, and A is 1 2 2 3. This is also same. Okay, so A square is same, 1 2 2 3. So you can see here our A transpose and A both are equal. Here A and A transport both are equal. So what will happen? We will get relation like this. A square will be equal to A transpose into A, and A transpose and A both are equal. So A square is equals to A transpose into A. Okay. So this is third question. Now move to the fourth question. In fourth question, we are again asked question about matrix. So here matrix is given A, and we are asked that which condition this matrix satisfy. So for this type of question, we have Cayley-Hamilton theorem, which state, according to Cayley-Hamilton theorem, we have relation mod a minus lambda I is equals to 0, and here a is given to us, and what is a? A is like 2 0 0 3 2 0 5 13 2, then minus lambda I is unitary matrix, it is 1 0 0 0 1 0 and 0 0 1 is equals to 0. And we have to find matrix determinant of this. So this will be 2 minus lambda, this will be 3 minus 0, so 3, 5 minus 0 5, 0 minus 0 0, 2 minus lambda, so 2 minus lambda, 13 minus 0, so 13, then 0 minus 0 0, 0 minus 0 0, and 2 minus lambda is equals to 0. So now solving this determinant, we get 2 minus lambda, and this 2 minus lambda square is equals to 0. So it will be 2 minus lambda cube is equals to 0. And now we substitute a instead of lambda, so it will be 2 minus a whole cube is equals to 0. So a is matrix, so here 2 should not be number, so I write here 2i because a is matrix. So the correct answer will be 2i minus a whole cube. So the correct option is 2i minus a whole cube. Then fifth question. Transpose in A 13, then 0 minus 0. Then fifth question is, given psi is equals to 2 phi 1 minus 3 phi 2 plus 6 phi 3, then find the probability of finding particle in phi 2 state. So in such type of question, we write our wave function as psi is equals to some normalization constant, and then for function that will be 2 phi 1 minus 3 phi 2 plus 6 phi 3. Then what we do, we put normalization condition and find this n. So putting normalization condition, so first of all multiply n inside, so it will be 2n phi 1 minus 3n phi 2 plus 6n phi 3. So normalization condition generally says, suppose I have wave function like psi is equals to c1 phi 1 plus c2 phi 2 plus c3 phi 3, then normalization condition says that c1 square plus c2 square plus c3 square must equal to 1. So here I have coefficient like 2n, then 3n, 6n. So I put normalization condition like this: 2n square plus minus 3n square plus 6n square equal to 1. So it will be 4n square plus 9n square plus 36n square is equals to 1. So it will be 9, 10, it will be 13 n square plus 36 n square is equals to 1. Okay, then it will be 36 plus 13, 6, 3, 9, 3, 1, 4, 49 n square is equals to 1. So n square will be 1 upon 49, and then n will be 1 divided by 7. Now substitute this n value in this wave function. Okay, so it will be psi is equals to 2n1, so it will be 2 by 7, phi 1, then minus 3n, so 3 by 7, phi 2, then forget it, look at here, 6n, so it will be 6 upon 7 phi 3, and we are asked question for probability of state in phi 2, so probability will be coefficient of phi 2, and that is 3 by 7, so it will be 3 divided by 7, 3 divided by 7 will be 0, 48, 28, 30, 28 will be 2, and 0, 14, it will be 6, 8, it is just like 0.42, so our correct answer will be option B, okay, 0.43. So these 5 questions are for today. So I finish here. Okay, this is our last question. Okay, thank you.